Good morning, guys, and welcome to today's lesson. I am on Unit 16, page 18. I will be completing 1 and 2 and 3 with you today. Now, today is really nothing new other than they took what we did yesterday and the day before and put it into a word problem. We're still going to use exponential regressions. So that's when we're going to put it in the calculator. You go to Stat, Edit, and you put it in list 1 and list 2. Once you get your x and y in list 1 and list 2, remember you're going to go to Stat, arrow over to Calculate, and it is number 0, exponential regression. Those are the steps. I also gave you your steps. They're all written down on page 16 of the packet. So let's get started. It says, the table below, created in 1996, shows the history of transit fares from 1955 to 1995. State, now here you go, the exponential regression, and remember that's number 0, with the coefficient and base rounded to the nearest thousandths. This is new. When you round to the nearest thousandths, that's going to be 3 decimal places. Okay, then it says, after we do that, using this equation, so once we find the equation, we're going to determine the prediction that should have been made for the year 1998 to the nearest cent. When I round to the nearest cent, I know that is 2 decimal places. So let's take one thing at a time, and the first thing you're going to do is find your equation. So this is exactly what you did yesterday in Delta Math. This is your x values are going to go in list 1. These are your y values are going to go in list 2. Pause the video right now and plug them in. Welcome back. Once you plug them in, we're going to use our calculator, and you're going to go to Stat, Calc, and you're going to go to 0, keep hitting enter, and you're going to have y equals a b to the x, just what you did yesterday. The only thing is now you're going to have to round. So when I round to the nearest thousandths, 3 decimal places, I get a is 0.002 and b is 1.070. I don't want you to worry too much about the rounding. Do the best you can with it. I will not mark it wrong if you round a little bit incorrectly. Not done yet because I have to write the equation. Y equals 0.002 times 1.070 to the x power. That's your equation. So we found the equation from the table. There it is. That's the first part. The second part says, using this equation, determine the prediction that should have been made for the year 1988. Now, we want to plug the year 1988 in for x. But if you look at your table, and this is the only little tricky part, 55 really stands for 1955. 60 is 1960. 65 is 1965. So if I'm using 1998, I know 98 will be x. So the only thing you do is you're just going to plug in x equals 98. You're going to plug it into your equation for x. Don't go to y equals. You stay in your regular calculator. So it's just a calculation. You're going to plug in 0.002 times 1.070 and to the 98. That is what you're going to plug in. Remember, you use the arrow up. This goes in for x, the 98. When you plug it straight away into your calculator, do it now, you're going to get 1.52. That's money, $1.52. So in 1998, the fare will be $1.52. Now, if you look at your table, it does make sense because in 1995, it's $1.50. So in 1998, it does make sense that it would be $1.52. And that's it. So let's look at number 2. A cup of soup is left on the countertop to cool. The table below gives the temperatures in degrees Fahrenheit of the soup, recorded over a 10-minute period. Write, here we go, write an exponential regression. I know that's the number 0. For the data, rounding all values to the nearest thousandth. So again, they want me to round to the nearest thousandth, which is 3 decimal places. So try it. Go to list 1, go to list 2, plug them in, and see if you can get your equation. So pause the video now, plug them in, and see what you get. Welcome back. I got y equals a b to the x. So when I rounded, I got a. Let's see how you guys did with rounding. 180.377 because I'm rounding to the nearest thousandths. And b is 0.954. Not done because I have to put it in my equation. Times 0.954, and that's to the x. So that, let me erase this so it looks a little nicer. And write that down. And this is my equation. I got my equation right there. Done. Now, it says nothing else, so you're done with that problem. They don't tell you or ask you to do anything else. There's no plugging in. So now let's look at number 3. What I want you to do is pause the video and do number 3. After you pause the video, do number 3, replay the video, and watch how I got the answer. And then compare your answer to how I did and see how you did. Then I want you to send me a picture of number 3 or just the answers with a little sentence on how you did on number 3. What did you think of it? How did you do it? What mistake did you make if you made one? So pause the video now. Okay, guys, welcome back. Here goes number 3. Here's how we hopefully did this one. This is list 1. This is list 2. So we plugged in to my list 1 and my list 2, and I got my equation. Now, it says the data collected by a biologist showing the growth of a colony of bacteria at the end of each hour are displayed in your table. They want the exponential regression, and again, nearest thousandth. So I know that is 3 decimals after, 3 places after the decimal. So I copy a, b to the x. A, when I round it, I get 215.983. B, when I rounded it, I got 1.652. How'd you do with the rounding? Now, I don't care if you're off a little bit with the rounding. I don't want you to worry about it. Then I'm going to write my equation because what they're asking for is an exponential regression, which is an equation. We can't forget to just plug everything in. 215.983, it's a lot to write, times 1.652, and you raise that to the x power. There is my answer. That's my equation. Now I have another part. Assuming this trend continues, use this equation to estimate to the nearest, now here, be careful, nearest 10. That's the nearest whole number in the tens place. Okay, a bacteria in the colony end of 7 hours. So I know, I don't even have to figure it out like I had to do with the date, the years. Here, I know that x is going to be 7. So I go straight away to my calculator and I plug it in. And that's going to be raised to the 7th power. That's the only thing I do. Hit enter, and I'm going to round to the nearest tens place. I got 7,520. So that's how much bacteria will be there at 7 hours. And I'm done. So, like I said, I want you to send me a picture or send me a comment. Let me know how you did on number 3. Hopefully you were able to complete it and understand. And I will see everyone tomorrow at the Zoom meeting. We'll do 2 more questions like this. Have a good day.